Hello everyone, welcome to the webinar today. We are still looking at the fractions unit on the General Math 1 course, and this is the last session in the series for fractions. Today we will look at multiplication and division for fractions. Before I go ahead and start my webinar, I'd like to introduce myself. My first name is Miriam. I'm the math instructor here at Penn. I did join the team in 2015. I am certified to teach high school math in the state of Pennsylvania since 2010. And also I did earn my master's degree in education last year. Basically, today we're going to go over the rules that we have to go by when we multiply and divide different combinations of fractions, mixed numbers, whole numbers. We're going to learn about the reciprocal when we divide. We're going to learn that division is essentially multiplication. We will also learn how to use the cancellation method. Before I start my presentation, I would like to remind you that if you are registered to attend this webinar, or whether you did not attend today or with us today, you will get a recording of the webinar later on, about like 5 hours after the conclusion of today's live session. So keep an eye on a follow-up email with the recording. Also, if you have a question during the session and you think it's a relevant question to what we say about the lesson today, you're able to type in your questions in the questions box that you see on your screen. The raise your hand feature does not work in our webinars. So to start with, let's look at simple questions about multiplication. So here on the screen, you will see simple fractions that we're trying to multiply, no mixed numbers, no whole numbers. Later on, we will combine mixed fractions, and we'll see different types of questions regarding multiplication and division. So the good thing about multiplication and division that we do not have to have the same denominator to multiply or divide. If you remember from the last session, or if you can go to our YouTube list for playlist for the fractions unit, you will see that we did mention about addition and subtraction. They are a little bit harder because you have to make the denominators common first, and then you'll be able to add and subtract. In division and multiplication, they do not have to have the same denominator. To multiply, it is better to go ahead and cancel out any common fractions from any number on the top with any number on the bottom. So that way, when you multiply, your answer will probably be in simplest form. I mean, you can go ahead and multiply across 3 times 15 and 5 times 12. You will get an ambiguous answer, and you still have to simplify your answer. The better way to do that is to cancel out again any common factor between the top numbers and the bottom numbers. For example, question number A, you have 3 over 5 times 15 over 12. We're going to look at the numbers on the top and the bottom and try to eliminate any common factors by division. So I see 15 and 5, and right away I realize that 5 is a common factor between 15 and 5. So I'm going to divide over 5 on the top and the bottom. So for example, I cannot do over 3 and over 3. I mean, I can do for the 15 and the 12, but for example, I cannot do 15 over 3 and 3 over 3. These two numbers are on the top together. We cannot do that. We have to eliminate a common factor from a number on the top with a number on the bottom. So far, our question is 3 divided by 1, because 5 over 5 is a 1, times 15 divided by 5 is 3. So we have 3 over 12 so far. Now, if I see another common factor that I'm able to eliminate, I can do another round of our cancellation method. I see 3 and 12, so divide over 3, or you can do divide over 3 here and then divide over 3 on the bottom. So again, we're eliminating the 3 from a number on the top and a number on the bottom. And rewrite the question again. 1 over 1, because 3 over 3 is a 1, and we have a 1 already on the denominator. So it's a 1 over 1 times 3 over 4. Now, we see that 1 and 1, nothing common, 3 and 1, nothing common, 1 and 4, nothing common, 3 and 4, nothing is common. So we're done with the cancellation method. We cannot simplify our question before multiplying anymore. So the next step is to multiply across. Multiply the numerators together and denominators together. 1 times 3 is 3, and 1 times 4 is 4. Now look at the answer, 3 and 4, nothing common. We cannot simplify further for the answer, so your product or your answer for this multiplication problem is 3/4. I'm reminding everyone who had just joined the session, you're able to ask your questions, keep them relevant, please, in the questions box. The raise your hand feature is not enabled in our webinar. So again, we're going to repeat the same process with any multiplication question that we see on the screen. First, eliminate any common factor from a number on the top and the bottom. Try to do as much elimination as you see, and then at the end, multiply across. Number B, 200 over 150 times 16 over 27. Whenever I see any two numbers ending with a 0, I know that 10 is a common factor. So divide over 10 and divide over 10. Rewrite the problem. So 200 over 10 will give you 20. And then 150 over 10 will give you 15 times 16 over 27. We did not touch that second fraction yet. Now look again, are we able to find another common factor from any number on the top and any number on the bottom? Well, I see 20 and 5. Any two numbers ending with a 0 and 5 will have a 5 as a common factor. So divide over 5 and divide over 5 equals 2. Rewrite your question. So it's going to be 4 divided by 3, because 15 over 5 is 3, and then times again the second fraction. We did not eliminate anything from it, so it's going to stay the same in equals 2. Let's check if we are able to eliminate anything else. 4 and 3, nothing common. 4 and 27, nothing common. 16 and 3, nothing. 16 and 27, nothing. So we just multiply across. So 4 times 16 will give you 64 on the top. And then 3 times 27 equals to 81 on the bottom. You're able to use a calculator whenever you feel you're not gonna be able to manually multiply 4 times 16 if you wish. I use a calculator just because we're not learning how to manually multiply. We now are learning how to multiply fractions. So I would rather focusing my mind on the process of multiplying fractions rather than just, multiplying two whole numbers. I can just do that with a calculator, and it's up to you at the end. So 64 over 81, nothing common to eliminate. But this answer is not in simplest form, because if you remember from the last webinar and the first webinar in this series, an improper fraction will make our answer not in simplest form. We have to put our improper fraction in a mixed number form. So if you remember, we asked the question, how many times 81 will go into 64? So 64 and 81, that is a proper fraction. My bad. So this is in simplest form. So 64 over 81 is a simplest form, again, because it's a proper fraction. If it was not a proper fraction, we will have to change it to a mixed number. I'm sure down the road we will have some examples where we have an improper fraction, and we will remember together how to put it in mixed number form. But as of now, this is the right answer. This is in simplest form, and that is it. So the product of these two fractions, 64 over 81. I'm just reading some of your questions. Okay, so I have questions on number C. 35 over 12 times 60 over 7. So again, when I see 35 and 7, 35 is on the top, 7 is on the bottom. Right away, I'm going to use 7 as a common factor because I know the multiplication table of 7. So I'm going to use the knowledge for that. So I'm going to divide over 7 and divide over 7. and rewrite the question. Some students would like to do too many cancellation steps in one step and then rewrite the question again. I personally, if I'm starting to learn how to multiply fractions, I do it one step at a time. So whenever I divide over 7, I just stop and rewrite my problem. If I have to eliminate again, I'm going to rewrite my problem again. So that way I'm going to eliminate any confusion or any mistakes, especially if I'm still learning how to do multiplication. So 35 over 7 will give you, of course, 5 over 12 times 60 over 1, because 7 over 7 is a 1. And then look again, 60 and 12. From the multiplication table of 12, we know that 12 times 5 will give you 60. So divide over 12 and divide over 12. So it's going to be 5 over 1, because 12 over itself, it's a 1 times 5 over 1. Look at the numbers, 5 and 5, nothing common, 5 and 5, nothing common. The same thing with the other fraction. I'm done with the cancellation method. So I'm just going to go ahead and multiply across. 5 times 5 is 25, and 1 times 1 is a 1. 25 over 1 is a whole number, 25. So your answer actually is not a fraction, it is a whole number. Is it possible that when you multiply two fractions, you can get a whole number? Yes. If you get a whole number as your answer and you did every single step correctly, then that's it. This is your answer. It does not have to be a fraction. Any question on this slide? Anything that was not clear on the steps that we did follow so far to multiply two fractions? You can type in your questions in the questions box if you have any questions. Okay, let's move on to a self-check question. The self-check questions, again, as you used in my webinar, my webinars so far, self-check questions are not graded. They are not part of your grade for this course. They are given throughout this webinar just to give you a chance to practice and do whatever we have learned on that one topic during our webinar. So again, this is a question, 3 over 12 times 18 over 9. How would you multiply these two fractions? We're going to follow the same steps. Cancellation method, you cancel out all the factors until there's nothing to be canceled out, and then multiply across, and then you can go ahead and select your answer. In about a minute or so, I'm going to change my screen to give you the same question with the same answer choices, but this time you are able to actually submit your answer. So you can get a piece of paper, a pen, or a pencil and write down the problem. Try to follow closely the steps that we had followed so far for multiplying two fractions. So you're supposed now to have a piece of paper, write down the question, and you should be starting thinking about the factor. Which factor we're able to eliminate, if any, from a top and a bottom number? Do you see anything that would click in your mind saying this number should be a common factor, so we should divide over that factor? What do you think? 18 and 9, what do you think? Three and 9 is another option. Thank you. Okay, so I'm going to change my screen, and you'll be able again to choose your answer and submit it. And here is the question, the same question, and here is the same answer choices. Which product is the right product for 3 over 12 times 18 over 9? Is it 1 over 6, 1 over 7, a half, or 1 over 4? I'm just going to wait for a few seconds for everyone to have a chance to submit their answers. Again, these are not graded. I'm not gonna go ahead and trace back who did get that correct and incorrect, or email them back saying, hey, why didn't you get that correct? I'm not gonna do that. This is really for your practice. Okay, let's then do the question together and see. And if you happen to know that your answer was not correct, it does not mean that fraction is impossible to be understood. It's not that the question will judge your understanding to fraction. This is actually a guide to you. If you did not know how to multiply the two fractions on screen, you still have time. Go back to the study unit, do some readings, ask questions, reach out for help. So again, 3 and 9, or 18 over 9. I'm going to do 9 and 9. And that will make me write the problem as 3 over 12 times 2 over 1. Because 18 over 9 is a 2, and then 9 over 9 is a 1. Let's see if I'm able to eliminate another factor, 3 and 12, or 2 and 12. Let's do over 2 and over 2. What's going to happen to the problem? It's going to be rewritten as 3 over 6 times 1 over 1 equals 2. Well, I have 3 and 6, so over 3 and over 3, and that will give me 1 over 2 times 1 over 1, multiply across 1 over 2, and this is the correct answer, number C. If you got the answer correct, good job. If not, do not give up. Just go back to your steps and see why you did not get the correct answer. Let's move on to another type of multiplication. What if you are asked to multiply two mixed numbers? What should we do? Are we gonna multiply 2 times 3 and then multiply the half and the fifth the same way we did previously, or we have to follow another method? Well, the method I just mentioned, multiplying 2 times 3 and then multiply the fraction separately, is not the right method. We have to change every mixed number to an improper fraction first, and then follow the steps that we have been following for multiplying the fraction. So 2.5 is a mixed number. The improper form for that mixed number is 5 over 2. And how did I get 5 over 2? 2 times 2 is 4 plus 1 is 5, and keep the denominator the same. If you're not sure how to change a mixed number to an improper fraction, go back to webinar number 1 in this series, and we did go through lots of practice about that. Times, this is another mixed number. We cannot keep it as is. We have to change it to an improper fraction. 3 times 5 is 15, plus 1 is 16 on the top, and keep the denominator the same, 5. Now, this looks like the same problems that we have been dealing with in the first section of the webinar. So I'm going to look for eliminating factors. I see a 5 and a 5 right away. Divide over 5 and divide over 5 equals to, rewrite the problem, 1 over 2 times 16 over 1. What else? I have 16 and 2. So 2 is a common factor. Eliminate that and rewrite the problem. 1 over 1 times 8 over 1. Now, nothing common between these four numbers, then multiply across. 1 times 8 is 8. 1 times 1 is a 1. 8 over 1 is a whole number 8, and this is your product. Any question about the first question A on the screen? Okay, let's do the same thing with B. The only difference in B is that we have a mixed number and a fraction. So we are not going to change both. We're only going to change the mixed number to an improper fraction, and the second one will just stay as is. And then we're going to do the cancellation method and then multiply across when done with canceling out all the common factors. So 1 times 3 is 3 plus 2 will give you a 5 over 3 times 6 over 12 is already in fraction form. So we're going to do the elimination or the cancellation. I see 6 and 12. I am able to divide over 6 and divide over 6, rewrite the problem. 5 over 3 times 1 over 2. Do I have anything else to eliminate? 5 and 3, nothing common. 5 and 2, nothing. 1 and 3, nothing common. 1 and 2, nothing. I am ready to go ahead and multiply across. 5 times 1 is 5. 3 times 2 is 6. This is a proper fraction, nothing common, so this is our answer, 5 over 6. Question number C on the screen that you see, 7 over 10 times 1 and 8 over 10. Again, we have a fraction and a mixed number, so we're going to rewrite the problem as 7 over 10 times, change the mixed number to an improper fraction. 1 times 10 is 10 plus 8 will give you 18 on the top, and 10 will stay on the denominator. Now be careful, some students would eliminate 10 and 10, because when you see a 10 and a 10 on both fractions, you get excited. You say, oh, 10 and 10, just eliminate them. Remember, we have to eliminate the common factors between two numbers. One has to be on the top and the other one has to be on the bottom. The two tens here are both on the bottom. We cannot go ahead and cancel out the tens. So let's look at the numbers on the top and the bottom. We have 18 and 10. I can divide over 2. Both are even numbers, so 2 must be a common factor. So rewrite the problem. 7 over 10 equals 2. 18 divided by 2 is a 9, and 10 divided by 2 is a 5. Do I have anything else to eliminate? 7 and 10, nothing common. 7 and 5, no. 9 and 10, nothing. And 9 and 5, nothing. So I am ready to go ahead and multiply across. 7 times 7 times 9 will give you 63. And then 10 times 5, of course, will give you 50. 63 and 50, this is an improper fraction. So this will make our answer not in simplest form. And here in this problem, we will have to change our answer to the mixed number form. So again, from webinar 1, we did go over in details how to change an improper fraction to a mixed number. We'll ask ourselves how many times 50 will go into 63. And we said in that webinar, if you're not sure, then grab your calculator and divide 63 divided by 50. It will give you a whole number and a decimal digits. Ignore the digits in the decimal, but you have to take the whole number, which is going to be a 1 if you try it on your calculator. 50 will stay in the denominator as is, and to determine the remainder or the numerator of that mixed number, you simply multiply 1 times 50 will give you 50, and then subtract 63 minus 50 will give you the remainder 13. And this is the final answer. 1 and 13 over 50 is the final answer or the final product. Any questions? Okay, let's go to a self-check question on the same topic. A mixed number times a mixed number. What do you think? We are not going to use the cancellation method, remember now, because we have to rewrite our problem using improper fractions, and then we can look for factors to eliminate. Again, rewrite the question. I find myself when I learned how to do problems, when I rewrite the problem myself as I am writing the problem, I'm comprehending the problem. So when I write 1 and 5 over 6, my mind realizes that it's a mixed number. And the back of my mind say, well, we're not going to multiply right away. We will have to do a step, which is changing that mixed number to an improper fraction and so on. So try to write the problem, look at the problem, decide the order of the steps that you're going to go through to find the correct product. Remember, when we change the mixed number to an improper fraction, you multiply the whole number times the denominator and then add it to the numerator. So you want to do the same thing on both mixed numbers and then decide on the common factors to eliminate. I'm going to give another few seconds, and then switch my screen to where you're able to submit your answers. Okay, let's see the problem again with the same answer choices. What do you think? What is the product of multiplying 1 and 5/6 times 5 and 2/6? Which one is the correct one? A few more seconds, and then I'm gonna do the question together. I hope that everyone has a chance to participate again. Those questions are not counted towards your grade. These are practice for you, as we do in traditional classroom. The teacher will put a problem and go around and see how everyone will do the problem. We just do it the virtual way. So take the chance that this is a live session and you're able to do the practice questions and ask your question to a real person. So you're able to then go back and study your unit and then make sense of things that you did not really understand when you first read the study unit yourself. Okay, let's do the question together. So again, multiplication problem. Once I see mixed numbers, I'm just going to hold. I'm not going to do any multiplications yet. I have to rewrite my problem in terms of improper fraction. 1 times 6 is 6 plus 5 will give you 11/6. And then times, you're going to change the other one. 5 times 6 is 30 plus 2 is going to give you 32 and keep the same fraction 6. Now we can think about the factors to eliminate. I see 32 and 6 both are even numbers. Then 2 must be a common factor I'm able to eliminate. So rewrite the question. 11/3, because 6/2 is 3 times. 32/2 will give you 16 at the top, and 6 will remain. Let's look. 11 and 3. Nothing common. 11 and 6, nothing. 16 and 3, nothing. And 16 and 6, nothing to eliminate. Well, 6 and 16 actually are even numbers, so I'm able to eliminate further. So 11/3 times 6/2 will give you 8, and then 3 on the bottom. Now 11 and 3, nothing, and nothing, nothing there, and then nothing with the 8 and 3. Now I'm able to multiply across. 11 times 8 is 88, and then 3 times 3 is 9. This is an improper fraction. I need to switch it back to the mixed number form. How many times 9 goes into 88? I know that 9 times 9 is 81, so it is 9 times. I'm going to keep the original denominator the same, and then I'm going to figure out the remainder. 9 times 9 is 81. 88 minus 81 will give you a 7. So the product for this problem is 9 and 7/9. So B is the right answer. Any questions about that problem? We will do more practice as we go along this webinar. Even division, you will see later that we will have to change into multiplication, and that will give us more practice with multiplication. Next, let's look at another topic about multiplication. What if you are multiplying with a whole number on the question? What should we do? We know the mixed number, we know we have to change that to an improper fraction. What about the whole number? Well, the answer is the same. We have to change the whole number to the fraction form. Well, anything over 1 is itself. So I'm able to rewrite this question as 10 over 1. It means the same thing, it just in a different form, 10 over 1 times. I cannot keep this as is. We did see in the previous set of questions, we have to change it to the improper fraction form. 1 times 40 is 40 plus 31 will give you 71 over 40. Now we can do the same exact process. Look at where you can eliminate things over 10 and over 10. Rewrite the problem. So repeating all of the steps again. The only difference is if you have a whole number or mixed number in the question, you have to prepare the question before you go ahead and do your cancellation steps and multiplying across. That's it. So 10 over 10, of course, is a 1. You have a 1 again on the denominator times 71 over 4. Nothing common between these four numbers. So I'm going to go ahead and multiply across. 1 times 71 is 71. 1 times 4 is a 4. This is not in simplest form. How many times 4 goes into 71? If you're not sure, use a calculator. 71 divided by 4 will give you what? Will give you 17 and some decimals. Ignore the decimals and take the 17 over. And then 4 will remain the same. It's the denominator. Find out the remainder. 17 times 4, and then subtract the 71 from that product. That will give you 3. So 17 and 3/4 will be the product for this question. The second question, the same concept. So 30 times a fraction. I'm going to change the 30 to simply 30 over 1. Just to have a denominator there, times, well, this is a fraction. I don't have to change anything on that problem. So it's going to be the same. Now I'm going to do my cancellation steps. I see, for example, 30 and 21. Well, I can divide over 3 here. And of course, I can divide over 3 here. Rewrite the problem. 30 divided by 3 is a 10. You have a 1. And then times 14. 21 over 3 is 7. Oh, 14 and a 7, divide over 7 and divide over 7. And that will make us write the problem as 10 over 1 times 2 over 1. Nothing common between anything. Remember that 10 and 2, we cannot eliminate the 2 because both numbers are on the top. So that's it for the cancellation. 10 times 2 is a 20. 1 times 1 is a 1. Our answer again is a whole number 20. Any questions? Anything that was not clear on how we multiplied two fractions with one of them being a whole number initially in our problem? Okay, as you know, there is a self-check question on this topic, 9 times 1 and 1 over 6. Am I going to change the two numbers there or just only one? And how I'm going to change the 9 to a fraction? Do I have to change the 1 and 1 over 6 to an improper fraction or no? Write down the problem, think about it, and rewrite the problem so you're able to start doing the cancellation steps. Okay, let's look at the question again on the different screen. And please participate in this question and enter your answers. What is the product of 9 times 1 and 1 over 6? You need to rewrite the 9 as what? And you need to rewrite the mixed number as what? What would be the factors to eliminate? Few seconds for everyone to get a chance to enter their answers. Okay, let's do the question together. So again, a whole number, we cannot just keep it like this. We are multiplying fractions, so we have to change it to fraction form. 9/1 times, this is a mixed number, we cannot use it as is. 1 times 6 is 6 plus 1 is 7, and keep the denominator the same. Now we can look for fractions for factors to eliminate. Over 3 and over 3. Rewrite the problem. 9/3 is a 3 over 1 times 7 over 2. Nothing to be eliminated here. That's it. So multiply across. 3 times 7 will give you 21, and 1 times 2 will give you 2. How many times 2 goes into 21? We know from the multiplication table that 10 times 2 will give you 20, the closest to the 21. So it's going to be 10, whole number. 2 will be the denominator. 10 times 2 is 20. 21 minus 20 will give you the 1. So the product is 10.5. So number A is the correct answer. Any question on how we got this product, or any question on one of the steps that we did on the screen here? Okay, let's move on to division. As I said at the beginning of the webinar, we will realize in a second that division is actually done by changing the problem properly to a multiplication problem, and we will do the same steps, cancellation, and then multiply across. But before we're able to change that, or multiply, I mean, we have to change the problem properly to a multiplication problem. When we have a division for fractions, a fraction divided by a fraction, it is equivalent to multiplying the same first fraction times the reciprocal of the second fraction. A reciprocal of a fraction is the flip of the fraction. So I'm going to be able to do the division or find the quotient of this problem by rewriting this division problem as this. 5/3, keep the first fraction as is, change the sign to multiplication, but you have to use the flip of the second fraction, the reciprocal of the second fraction. Well, it was a 12/9, so it'll become a 9/12, the reverse of the fraction. Now it's a multiplication problem. If I multiply times the reciprocal, that will be equivalent to dividing over the original second fraction. So if I'm able to cancel out the factors, multiply across, I'll be able to find the quotient. Equals to, look at the numbers, what should I eliminate here? Well, I have 9 and 3, so of course I'm going to do over 3. Rewrite the multiplication problem. 5/1 times 3/12. Again, I have 3 and 12, then eliminate the 3 and eliminate the 3. Rewrite the problem. So we're going to have 5/1 times 1/4. Multiply across. 5 times 1 is a 5, and then 1 times 4 is a 4. This is not in simplest form. The quotient has to be in simplest form, so this is equivalent to 1 and 1/4. And this is the quotient. This is the result that we get when we divide 5/3 divided by 12/9. Any question about why we changed the division to multiplication this way? Okay, let's do number B, the same concept. 25/60 divided by 20/5. Now, both of them are fractions. I'm going to keep the first one the same, 25/60 times, and then flip the second fraction over. That would be a 5/20. Now, one common mistake I have to point at before I proceed is that I have seen in the past that students would eliminate the 5s from the 25 and the 5 with the division sign there. This is not correct. We have to use the cancellation method after we change the problem to multiplication. So we cannot do over 5 and over 5 at this point. We cannot do that. That is not correct. We have to change the problem properly to multiplication in order to use the cancellation method. We cannot use it before that. And you see here, when we did change the question to multiplication, we cannot anymore divide over 5 and divide over 5 because both numbers now are on the top. So that will lead us to the incorrect answer. So we did switch the question to multiplication. Now we'll think about the factors. Well, I have 25 and 20 divide over 5 and divide over 5. Rewrite the problem. It's going to be 5 over 60 times 5 over 4. Okay, what else? We have 60 and 5 over 5 and over 5. And that will equals to 6 over 12 times 1 over 4. Now, nothing to be eliminated. We have I'm just reviewing my, oh, this is a 5 actually. It's not a 6. So that is a 5 coming from here. So it's the same number, 5 over 12, and then times 1 over 4. So again, nothing is common. I'm going to go ahead and multiply across. It's going to be a 5 over 48. Nothing common between 5 and 48. It's a proper fraction. Nothing to be done further. This is the quotient. So again, we did find the quotient by changing the problem to a multiplication problem and also changing the second fraction to the reciprocal. So let's practice with this kind of problem. It's going to get harder, but this one is the simplest kind of questions with division. 27 over 50 divided by 3 over 10. What should we do? How can we change this problem to a multiplication problem? Are we going to change that second fraction to its reciprocal or no? Write down the question and rewrite the question as multiplication, and you can go from there as we exactly did in our multiplication problems. Okay, I'm going to change the question to give everyone a chance to share their answers. What is the quotient of dividing 27 over 50 divided by 3 over 10? We know how to change this problem to a multiplication problem using the reciprocal of the second fraction. What is the reciprocal of 3 over 10? What is the reciprocal of 3 over 10? Then think about the factors to eliminate from a number from the top and a number from the bottom. Since it became a multiplication problem, we would do the same steps as we did as if it is just a multiplication problem, has nothing to do with division. Okay, let's do the question together. So we're starting with two fractions division here. So I'm gonna change my question to a multiplication question. I have to do it properly. 27 over 50 times the reciprocal is 10 over 3. Look at those two numbers, eliminate 10 and 10. Rewrite the question, 27 over 5. And then times 1 over 3. Okay, again, I have 27 and 3, eliminate 3 and eliminate 3. 27 over 3 is a 9, and then we still have the 5 on the bottom, 1 over 1, and then multiply across. 9 times 1 is a 9, 5 times 1 is a 5. Put your answer in simplest form, so that would be a 5 and 4/5, and that is the quotient of dividing these two fractions. So the answer is D, 1 and 4/5. Question on how to divide two fractions. Anyone is not sure why we do what we just did on those questions? Okay, let's move on to a little bit harder kind of division. And you see mixed numbers here. So 2.5 divided by 1 and 1/4. Again, with multiplication, we had to change them first to improper fractions. The same thing with division. So the only trick that students would sometimes do a mistake on is that they change the question to a multiplication first, and then they do the change from a mixed number to an improper fraction. It has to be actually the other way around. We have to change each mixed number to an improper fraction first, and then change the problem to multiplication using the reciprocal of the second improper fraction, and then use the cancellation method if possible, and then go ahead and multiply across and simplify your answer if needed. So let's do the same then as we just said on problem number A. 2.5 is the same thing as saying 5/2 divided by, I'm not going to change anything to multiplication yet. Change the second one to an improper fraction. 1 times 4 is 4 plus 1 is a 5/4. Now we have a fraction divided by a fraction. Change it to a multiplication problem. Keep the first the same, times the reciprocal 4/5. Divide by 5. I'm going to use now the cancellation method since it's a multiplication problem. That would be 1/2 times 4/1. And I still have 4 and 2 to eliminate. So I'm going to divide over 2 and divide over 2. And that will give me 1/1 times 2/1. Multiply across. 1 times 2 is 2/1 is a 2. The quotient is 2. Same thing with the second question. I have a mixed number. I cannot do anything. I cannot change the problem to multiplication yet. 3 times 5 is 15 plus 2 will give you 17 on the top, and then 5 divided by 5/15. Now change the problem to multiplication. So it's going to be 17/5 times the reciprocal 15/5. Look for factors to eliminate. I can divide over 5 and 5. Rewrite the question. You have 17/5 times 3/1. Nothing to be eliminated further. So multiply across. 51 divided by 5. Nothing to be eliminated. Just change it to a mixed number, and you will find it's a 10 and 1/5. So this is the quotient for dividing this mixed number over this fraction. Any questions? Okay, let's go to a self-check question. We are dividing two mixed numbers. What should we do first before we change the question to a multiplication question? So we have 11 and 1/2 divided by another mixed number 5 and 1/12. What is the improper fraction form of the first number and the second number? And then you change the question properly to multiplication. Find the factors to eliminate. Multiply across when you're done with the cancellation method, and simplify your answer if possible. few more seconds for everyone to get a chance to share their answers. What is the quotient for this division problem? What do we do first? Okay, let's do the question together. So again, as we did before, we cannot change the Okay, now everyone sees the screen. We cannot change the problem to a multiplication problem yet. We have to change each mixed number to an improper fraction as follows. 11 times 2 is 22, plus 1 is 23 over 2, divided by 5 times 12 is 60, plus 1 is 61 over 12. Now we change the problem to a multiplication problem. 23 divided by 2 times 12 divided by 61. Look for factors to eliminate. I see two even numbers. Divide over 2 and divide over 2 equals to 23 over 1 times 6 over 61. If you look at 6 and 61, nothing common. 23 and 61, nothing common. 6 and 1, of course, nothing. So I'm ready to go ahead and multiply across. 23 times 6 will give you 138 divided by or over 61. This is not in simplest form. How many times 61 goes into 138? Or the easiest way in this case, because we have weird numbers, we can do 138 divided by 61. It will give you 2 and some decimals. Ignore the decimals, take the 2. 61 will stay in the denominator, multiply. 2 times 61 will give you 122, subtract. 138 minus 122 will give you 16 on the top. Nothing common between these two numbers. This is your quotient, which is 2 and 16 over 61. So that is B. So I'm trying to see if you did get the right question. It seems I did launch the incorrect question. Maybe that's why I have different answers. You know what? I'm going to give you the poll again so you're able to enter your answers. Let me see. Okay, let's try this one and see if that matches the question. So again, if you'd like to repeat the process I just put on the screen, thank you. And try to see if you will arrive to the same answer. Okay, B was the right answer. And I'm gonna switch back to the screen where you see the work, and you can compare your work that you have on paper and see if that matches. Thanks for everyone who did answer the question, although I did the question before I put up the right question. Thank you. Okay, I'm gonna close the question. And again, here is the how we did find the question, the answer to be number B. We did change the question to improper fractions, change the problem to multiplication using the reciprocal, eliminate the 2's, multiply across, and then change the answer to mixed number form, and B is the answer. Okay, let's look at another kind of division. You know it by now. It's going to be a whole number in the question. So again, with multiplications, we did switch the whole numbers to a fraction form, the same thing. So I'm not going to change the question to a multiplication form yet. We have to change every mixed number to improper fraction and every whole number to a fraction form. So we're going to do 3 times 7 is 21 plus 1 is 22 over 7 divided by 2 over 1. Now we change the question to a multiplication question. 27 will stay as is times 1 over 2. Look at a factor to eliminate. Divide over 2 and divide over 2. And that will be 11 over 7 times 1 over 1. Multiply across will give you 11 over 7, not in simplest form. This is an improper fraction. How many times 7 goes into 11? Once, so it's going to be a 1. 7 will remain the same. 1 times 7 is 7. 11 minus 7 will give you a 4, so the quotient is 1 and 4/7. If you look through the webinar since we started, we have been repeating the same steps, but every kind of the question makes us do one or two steps to prepare the question first, and then we go through multiplication. Whether it's a multiplication problem or a division problem, we will have to at certain point change the question to multiplication and do the same steps. If it's originally multiplication problem, you may have to prepare the question changing the mixed numbers to improper fractions or whole numbers to fraction form, but you will follow the same steps: cancel the common factors and multiply across. I think everything is obvious at this point. We're just repeating everything. This is the last question on this topic. A whole number 2 divided by a mixed number 2 and 2/7. What is the quotient of dividing these two numbers? What should I do with the 2? What should I do with this mixed number? Am I going to change now to division, to multiplication, or keep it as division for now? What do you think? Two will become 2 over what? And then 2 and 2 over 7 will become which improper fraction? And then decide on how you change this properly to multiplication. Decide on the common factors you're going to eliminate once you change it to a multiplication problem. What would be the quotient of this problem? I'm going to change my screen to the right question, number 6, and here you go. What is the quotient of 2 over 2 and 2/7? Okay, let's do the question together. I appreciate everyone who shares their answer, and even if you decided not to share the answer but did work out the problem, thank you. That helps me and helps you too, because I'm putting time towards these webinars, and ultimately I want everyone to benefit from these live sessions. Okay, so again, it's a division problem. I'm not going to change anything else to, I'm not going to change anything with a problem to multiplication, because I really see lots of work to be done before we're able to do that. So 2 over 1 divided by, change that to an improper fraction. 2 times 7 is 14, plus 2 will give you 16 over 7. Now change it to a multiplication problem. 2 over 1 times 7 over 16. I see two even numbers, divide over 2 and divide over 2, equals to 1 over 1 times 7 over 8. That's it. I cannot eliminate anything further. Multiply across. That will give you 7 over 8. It's a proper fraction, nothing to be simplified. So the answer, the quotient, is B, 7 over 8. And that is it for my math part of the webinar. We did go over the many different kinds of questions in division and multiplication. We did learn how to use the cancellation method and when is the right time to use them when we are dividing two fractions. We did learn that sometimes we have to prepare our question if we see a whole number or mixed number in our questions, whether it's a multiplication or division problem. We learned also that division is essentially a multiplication problem, just you have to do it properly in order to arrive to the right quotient. Next, how do you prepare for the exam? Of course, you have to go through the unit and read the unit yourself. I've talked to students before and they say, well, I remember fractions from my middle school studies, so I'm just going to go ahead and, take the exam. You know what? You have two trials on the exams, the first attempt and the retake exam. But guess what happens? When you take the first exam without studying and you score a 30, for example, you get discouraged. So I do not recommend anyone just to go ahead and try the first exam just because they rely on their memory of how to do fractions, or they just attended this webinar and they think that this is enough. When you get a bad grade on an exam and you know that you did not prepare for it well, you get discouraged. So do not attempt any exam before you really do study everything available for you in this course or this unit. You can rewatch the webinar again whenever you receive the follow-up email with the recording. Within the lesson, we have some discover more questions or self-check questions, or it may be called a practice question. And also we provide the answer key for these. And this is for a reason, because if you're working on a problem and you get an answer, you never know if it's right or wrong. Compare your answers with the answer key. If most of them are correct, then it's a sign for you you're ready for the exam. If most of them are incorrect, please do not attempt the exam. You can reach out for help by phone, 9 to 6 Eastern Time on weekdays. You can schedule an appointment with an instructor or teacher assistant on a specific topic on that course using the link that you see on the screen. You can text message learn to this number if you have a brief question on your studies. You also can email or chat with your instructor or teacher assistant. If you go to your account, these two different looks of the account, but they function the same way. So if you go to the help center or help and support, from there, just follow the steps that correspond to your account. You'll be able to chat or send us an email. The same thing with all accounts, it just behaves the same way. With chats, we're only available from 9 to 6 Eastern Time again. With emails, you can email us any time of the day. We just cannot get back to you after operation hours. And thank you everyone for participating and attending this webinar. Even if you could not attend, I appreciate that you registered for the webinar, and I'm sure that you will watch the webinar after you get the follow-up email. There is a small survey, 3 questions only, will let me know how I did throughout the webinar, how I can improve the webinar, and what was good things that you thought it's valuable during this session. So it's only 3 questions. Even if you did not attend, you still have a chance to assess your experience throughout this live session. Do you have any questions for me? I'm still here for a few seconds to answer your questions on the topics, or maybe on the course, you're not sure about things. You can ask your questions. Okay, if you cannot think of any questions now, you still have an email address associated with this webinar. You can send your questions to this email address, and I'm very glad to answer you if it's relevant to the webinar. I wish everyone good luck in the exam, good luck in your studies, and I'll see you next time.